Have you ever wondered, what is the world made of? What you probably learned in school is that the world is made of atoms. Maybe you learned that inside every atom there are three basic parts: protons, neutrons in the core, and electrons whizzing around the outside. This image of an atom might be pretty familiar to us, but the truth is there's even smaller building blocks than protons and neutrons. But what are these tiny invisible building blocks? Understanding these teeny tiny particles is a branch of physics called quantum mechanics. The standard model of quantum mechanics goes like this. There's different types of building blocks that make up all matter, everything that we can touch and feel. There's 6 different types of quarks, 6 types called leptons, these include the electrons, 4 types of bosons, and the Higgs boson. Then there's also different particles that carry forces. For example, particles of light that carry electromagnetic force, and antiparticles. All these particles make up 61 elementary particles altogether. Essentially, the standard model says that with just 61 different types of building blocks, you can make up the whole universe and everything in it. Or so we thought. The problem with the standard model of quantum mechanics is that these 61 building blocks don't tell us everything about how the world works. For example, gravity. The standard model can explain part of how gravity works, but not all. There's no particle that we've discovered that explains gravity. But that's okay, we can use a different set of rules to explain gravity, called Einstein's theory of general relativity. Einstein explained that gravity causes space and time to bend around large objects. So we have 2 explanations for how the world works: quantum mechanics and general relativity. But when we try to put these 2 theories together, we get problems. Our theories break down. For example, black holes. Black holes are objects that have so much gravity that they crush space-time into a tiny point. But when we try to calculate what's going on inside a black hole using our 2 theories, we get results that don't make sense. A black hole is extremely tiny, like particles, but also full of gravity. Neither theory can explain black holes properly. So what do? We know something's not right with both of our theories. Neither theory can explain everything in the universe. They can only explain parts. So we need a new way to explain everything. That's where we come up with string theory. String theory is a new theory that explains not just gravity, but everything in one complete story about how the world works. That's why string theory is sometimes called the theory of everything. But what exactly is string theory? The idea is that instead of those 61 building blocks we mentioned before, all we have are strings. Instead of an electron as a tiny point, we actually have a tiny loop of string. Because these 61 particles are so tiny, from a distance they just look like dots or points or particles. But inside, they're actually a string. Like a string on a guitar, strings can vibrate in different ways. On a guitar, if a string vibrates at one note, we get a G sound. And if it vibrates a different way, we get a C sound. The same goes for strings. Different vibrations in the strings give us different qualities. So a string vibrating at one frequency might look like an electron, and at a different frequency, it'll look like a proton, but they're all one type of string on the inside. So instead of 61 types of building blocks, we have one type of string vibrating 61 different ways, or maybe more ways. Maybe there's ways that we haven't discovered yet. There's no direct experimental evidence for string theory. They're too tiny to be seen, even with the most powerful microscope or detector. Even with so many advances in science, we don't really understand fully how string theory might actually work. But if string theory is correct, scientists have finally found a way to explain everything with just one set of rules.
Hi everyone, I'm Jade Lovell, resident science nerd on the Young Turks Network. You're watching SciQ and we know you don't want to miss an episode, so please click the subscribe button down below.